Students, so today we'll go for the next IR complex frequency here with respect to the pyridine. Okay, with respect to the pyridine. Okay, so on complex formation, the pyridine vibrations in the high frequency region can see that they are not shifted appreciably. But if you see those of 604, okay, 604 nanometer, that is in plane ring deformation, we call it as a in plane, okay, in plane ring deformation, ring deformation, in plane ring deformation, okay. And at 405, 604 and at 405 per centimeter, okay, out of plane ring deformation, out of plane ring deformation, out of plane ring deformation, and in plane ring deformation 6 knot per centimeter and 4 knot 5 centimeter out of plane ring deformation. They are seem to be shifted to higher frequency. Okay, they are seem to shifted to higher frequency. Okay, this is what. And the second thing, this was being observed by Clark and Williams. Okay, so this was first seen by Clark and Williams, Clark and Williams, and they carried this experiment in far IR study, far IR infrared study on the metal pyridine complexes. Okay, and they have shown some of the vibrations. Main vibrations is metal to pyridine vibrations metal to pyridine. Okay, metal to pyridine vibrations, and that of metal to halide MX. Okay, metal to, as we have seen in last previous video also. And for the best example we have shown here is a FAC isomer and mer isomer of this complex, FAC and mer isomer of this complex, that is rhodium RH, pyridine thrice Py3 and Cl3, rhodium Py3 Cl3. This is a spectra we can see here. Okay, what is this FAC and mer isomer? So if you take this FAC and mer isomer, for example, if you take this type of Ma3X3 complex, okay, like this one, Ma3X3 complex. So what is the FAC here? So FAC is nothing but, so here like this complex will be there. So like C3V group notations, C3V notations. Okay, so you can see here. So here A will be here, and AX and EX. So such type of arrangement we call it as a FAC arrangements. Okay, we call it as a FAC, FAC isomer. Okay, and opposite of that, if it is A, if it is AX here, so AA is here. Okay, so if this is there, so we can take it as a FAC isomer. Okay, yeah, so I think it is A and X here. Okay, A and X. Then here you can take it as AX. How many X? And here A 1 2 3 and X, A and X, is it right? So 1 2 3 1 2 3, yes. So this is your FAC isomer. Okay, so here in the trans position you can see here A and X will be there. Okay, and here yeah, AA, you can take it in the same isomer, AA and X, like this. Okay, so this becomes your FAC type of isomer. And mer isomer means as I before I have what I had written here. So mer isomer, that is you can see both will be same here, A and A will be here, and you can see A and A, and here AX and AX, like this. Okay, so this will be the Ber isomer. Okay, this is how we can correlate to for the Ma3X3 type of, like this one, Ma3X3. So you should know what is FAC and Mer isomer. Okay, FAC means what? Different here. So A will be here, X will be here. So trans type of. Okay, so not same will be here. Then here AX, AA or XX, you can write it here. So this is a FAC, or AX, like this. So it will be FAC. Okay, mer isomers means same, AA you should write here, and remaining things will be here, like this, all others. So total 6 ligands will be there. So this is how the FAC and mer isomer we can represent. And you can see here in these exhibits of FAC and this isomers, they exhibit two rhodium C3V. So this is what I said you, C3V. So this exhibits the vibrations of rhodium pyridine. Okay, rhodium and pyridine, that is C2V symmetry, C2V symmetry here. So near 250 per centimeter, you can see here 250 per centimeter. This is 250 per centimeter. You can see the C2V is observed. It is of frequency of rhodium and iridium. Okay, the IR spectra. So you can see here of two complexes. Okay, two complexes you can see here, and the vibration spectra of this in the low frequency. They are assigned. So they are assigned here, and you can see here they are the FAC A1 is the A1 is a FAC here. So it is showing two. Okay, it's showing two vibrations here, whereas two bands here at 250 per centimeter, and the mer isomer you can see here. So it is showing three, 1, 2 and 3 at this frequencies here. So this is how the isomeric structures, if it is present, we can distinguish with the help of the IR with respect to such type of what you say complexes with respect to the frequencies whenever the pyridine is form complexed with the metal ion. Okay, so metal ion as well as the halide ion, so both is very much important. Okay, and you can see one more complexes have shown it here of the pyridine here with different metal ions: manganese, iron, cobalt, nickel, copper, zinc and cobalt here. And this is how the pyridine you can see here. So pyridine, you can see the band here, small band I have shown here, 600 at 600. Okay, 600, and at one at 400 here, 400 you can see the band here. And on formation of the complex with these metal ions, how they shift you can see here how the shift in the bands is being observed here. Okay, so this is also one of the study we can see correlate between the IR spectra here. Okay, with 650 to 150 650 to 150 per centimeter range, 650 to 150 per centimeter range of the complex of this complex, that is metal pyridine twice Cl2 complexes. Okay, so where we can see that the solid bands, these solid bands here, the solid band here. So this is a solid band. The solid bands they are representing the metal to Cl vibrations. Okay, metal to halide vibrations. And the shaded bands, that is the shaded here. So this is the shaded like this. This is shaded like this, like this. Okay, shaded band. This represents the vibration of metal to nitrogen of the pyridine bands. Okay, so here the bands you can see here. So new 1, new 2, new 3, new 4 I have shown it here. Okay, so these are the bands I have shown it here. New 1, so you can say so new 1, this is new 1, new 2. Okay, new 3, and new 1, new 2, new 1, new 2, new 3. Okay, new 4, and last one is this is new 5. So these are the vibrations. So you can see here. So the bands new 3 and new 4 here. So new 3 is which one? 1 2 this is new 3 here, new 3 and new 4, this one, new 3 and new 4, this one, that is shaded. Okay, not solid, shaded. So they represents the I said you shaded here. So they represent the frequency of metal to nitrogen here, while solid bands new 1 and new 2, these are the solid bands new 1 and new 2. So they represents the metal to halide. Okay, they represents the metal to halide, new metal to halide. Okay, so this is new 1 and new 2. Okay, so solid bands, so they are metal to halide here. So and the new 5, so here this one new 5, it has been assigned for the bending mode. So new 5, this one is assigned for the bending mode. They are assigned for the bending mode here. Okay, so new 5, so this assigned for the bending mode. Okay, so this is how we can vary the IR spectra for whenever they are going to be and new 1, new 2. Yes, new 1, new 2 have shown. I have told you new 1, new 2. That is solid bands, metal chloride bands. Okay, metal halide bands and bending bands. Okay. Now, if you see in the polymeric series of octahedral complexes. Okay, in polymeric series of octahedral complexes. Okay, if you see here, so what how we can show metal, then like this, pyridine, chloride, metal, Okay, chloride, metal, you can show it here, and it goes on like this, pyridine and pyridine. So here also pyridine and pyridine, so like this. Okay, so this is a polymeric. So if you see this type of polymeric what do you say, octahedral complex, so here both vibrations of metal to nitrogen, both vibrations of metal to nitrogen and vibration of metal to Cl, okay, they are follow the Irving Williams, they follow Irving Williams order. Okay, this thing you have to, they are going to follow the Irving Williams. What is this, we'll see Irving William order, so we'll see that in the next this one video, or if fact we will see if time permits, we'll go for today only. And you can see in this type of polymeric this ones, the two new MCl, and so two of these vibrations of metal to chloride, two vibrations of metal to chloride, and one vibration of metal nitrogen is to be expected, are expected here. Okay, so in this, from this structure you can see here, so two vibrations of metal chloride and one vibrations of metal to nitrogen pyridine, one vibration of metal to nitrogen is expected here. Okay, so this is what in IR spectra. So polymeric octahedral of C1 symmetry. So this will be expected at C1 symmetry. This is very much important. Symmetry is very much important. C1 symmetry. C1 symmetry of this. This is possible. Two vibrations of metal Cl and one vibration of metal I is possible here. Okay. Whereas if you see in C2V symmetry, if you change this symmetry to C2V, so same spectra you see here, how we can observe here for C2V. So we are expecting here two vibrations of metal Cl, okay, metal chloride, two vibrations and two vibrations of metal nitrate, two vibrations of metal nitrogen here. So this is how the change in the geometry C1 to C2V, C1 to C2V, C1 to C2V, the vibrations are differing here. Okay, so this is how this is how the IR spectra, the changes in this is very much important on we can say that here also you can see shifting and everything. So this is how the IR spectra helps us as an application part for knowing the isomeric form of the complexes, and different whether this is how geometry, so C2V and C1 symmetry, so how does how the vibrations are changed here from one MCl and 2 MCl and 1 M spectra peak here, so 2 like this. So this is how we can show that the application of the IR spectra is very much helpful for understanding the complexes of the pyridine. Okay, whenever they are going to form complex with the metal ion. Okay, so this is how I think hope you understood this of this pyridine complex. Okay, so amine complex and pyridine complex. So this is how you can make a small point on this and represent in the examination. And so amine over pyridine over, in the next video we'll see there is DMSO, and otherwise ethylene diamine acetato is there. So different ligands they have given in this lab. So we'll see the daily one by one the ligands, and we will see the changes in the spectra, how the change in the spectra we are observing upon binding with the ligands with the metal ions in presence of the halides. And this is how the application part we can learn. Okay, so hope you understood. Thank you. Have a nice time.